Hello biology students, welcome to the tutorial on how to do a correlation in Microsoft Excel versions 2007 or 2010. Before you do this tutorial, you should first do the tutorial on how to make a scatter plot. The scatter plot we made using these data is right here. The reason you do a graph before you do a formal correlation analysis is so you can get a visual appreciation of the type of trend you'd be expecting from the statistic. From this graph we can see that in general butterflies with a large wingspan also have long proboscis. Proboscis? I don't really know how to pluralize proboscis, but let's say it's that way. So a correlation is the type of test you should use when you are comparing two continuous variables, especially when there is not a causal relationship between the two variables. One variable does not cause any effect on the other. And that is indeed the relationship we have here. Wingspan and proboscis length. Large wingspan should not cause tongues to get longer or vice versa. This is a classic case where a correlation analysis is appropriate. So after you've made your graph as you have here, you want to do your correlation analysis. To do that, you click on the Data tab and you want the Data Analysis button. If you do not see the Data Analysis button in your version of Excel, don't panic. It's very easy to get this button. Just click on the Help button over here and type in, how do I install Data Analysis? And it will tell you. It's a straightforward process, it just takes 5 minutes. And then you've got this button and you can do some high-level statistics with this button. So we click it, it brings all these nice options of how to do data analysis. We're going to choose correlation. Hit OK. So the first part here is asking for the input, what to correlate with what. The input range, we're going to click here and tell it which two variables to correlate with each other. You just click and drag to highlight the two of them. Make sure you include the header row at the top as well. We want to check this box that labels are in the first row because our labels are in the first row. So obviously if you didn't highlight them, then don't check the box, but it's just going to be a little bit more work for you later when you have to tell Excel which variable is which. The output options is asking where to spit out the correlation table. The default is to make a new worksheet tab in your Excel file, but because we're only correlating two variables, it's a pretty small table. We might as well just throw it onto the same sheet that we're already on. So we're just going to tell it where to put it. Let's put the correlation table right there. So that's going to be the top left of the table. Okay. Good. So that's our correlation table right there. You can see our two variables, wingspan and proboscis length, are columns as well as rows. You can't read them both here, it looks a little messy because the columns are shorter than the text, but you can read the full text up here. The ones on the diagonal are uninformative. What they're telling you is that wingspan is perfectly positively correlated with wingspan. Likewise, proboscis length is correlated with proboscis length. What's most important here, the only thing that's important, is the correlation between wingspan and proboscis length. And that relationship is about 0.94. Round it to the nearest 2 decimals for correlations, that's all you need. The closer a correlation value is to +1, the stronger the positive correlation is. In fact, as you can see, wingspan is perfectly correlated with wingspan. The closer a value is to -1, the stronger the negative correlation is. For example, the more you smoke, the shorter you live. So in this case, 0.94, that's a pretty strong positive correlation. And that matches with what we can see in our graph. We see a pretty strong positive correlation here. So we we know the effect size of the correlation, we would type this as R equals 0.94. Our degrees of freedom is our sample size minus 2. So we've got 17 butterflies here that were the basis of our analysis. So you just take 17 minus 2, 15, that's our degrees of freedom. And then you can look in the appendix of your lab manual, on, I think it's page 128, for the table that gives you the relationship between correlation strength, Pearson correlation coefficients, and the critical threshold of significance. And I can see there that with the degrees of freedom of 15, 0.41 is our critical threshold of significance. Our Pearson correlation exceeds that. Therefore, our strong positive correlation is statistically significant. There is a relationship between these two variables. That's how you do a correlation.